This is a special type of new hologram technology that is completely different from everything else you've heard about holograms before. It doesn't use interference patterns like regular holographic films, nor is it a false hologram made using slanted screens like in the Tupac performance. No, this is a truly three-dimensional holographic object. In fact, you could even stick your hand into the hologram itself. This is all made possible through recent developments in levitation technology. And no, not magnetic levitation, but sound levitation. So what advances have been made? How do these advances enable this form of holograms? And when can we buy one? Let's discuss it. The concept of levitation has always been a fascinating one. There are so many benefits to being able to hold something above the ground without it physically touching anything. For quite some time, we have known how to make things levitate. Magnetic levitation is well known. You can take two magnets that repel each other to generate a force to hold the two magnets apart. Construct this in the right way, and you can have a stable method of levitation and propulsion. Thus, the invention of maglev trains. Levitation can also be achieved using superconductors. Superconductors in general repel magnetic fields, and this can be used for levitation. But there is one major problem with both these methods. They require magnets to work. So when you imagine a levitation skateboard like Marty McFly's from Back to the Future, it will look more like this actual version that is restricted to magnetic floors. But the year is 2022, and we are no longer confined to just magnetic levitation. We know that we can levitate many objects using an array of different mechanisms to apply the force required. We can even go to special rooms to do indoor skydiving. But what is interesting scientists now is not just levitation, but holding something exactly where you want it to be and being able to move it around at will. This has led to designs for a complex array of various tools to perform these tasks. One of the more exciting methods is to use sound. This is exciting for many reasons, so let's discuss how this works. Any form of levitation works by applying a force to counter the gravitational force. In order to do this with sound, force is applied by an interference pattern from overlapping sound waves. This way, the force from all the different waves can add or subtract to generate a force field known as a trap that opposes the gravitational force and can even push objects around in different directions. In essence, the interference pattern generates a pocket of higher pressure around the levitating object, such that if it moves in any direction towards the higher pressure, it will be pushed back towards the center. Now, this only works with light objects. Otherwise, the intensity of the sound would be very problematic to be around. To actually perform the levitation, the scientists combine an array of speakers and then adjust each speaker to get the required interference pattern. By knowing where the object is, scientists can calculate how to form the force field around it and to move it. Generally, this requires very well-known experiments, ideally a completely empty box, as reflections from other objects make it much more difficult to figure out the equations required to generate the fields. In this latest work, however, scientists have overcome this hurdle with some advanced computational code that can account for additional objects. With this upgrade, they are able to demonstrate that they could levitate beads above and around a 3D printed rabbit, and even levitate underneath an object. They even showed that you could use your hand to control where the bead was being levitated. This is extremely interesting, particularly when we think of the possible future of holographic displays that respond to human gestures. But how does any of this relate to holograms? Well, this comes in when these scientists combine the levitating beads with light. Basically, by moving the beads fast enough, the human eye can no longer tell where they are, rather they see the image of the shape of where the beads have been tracing out. If you then shine light onto the beads in the right way, then the reflections from the beads becomes an image, or in this case, a three-dimensional hologram. This really sounds like something out of a science fiction technology. Imagine having thousands of these beads, all levitating in different locations to make an image, and then combining with light and using the speed of the movement to introduce transparencies. This could really make extremely complex holograms. But we're still a long way off this level of technology. The scientists did demonstrate a butterfly flapping its wings, and they were also able to levitate a clear piece of plastic that acted as a screen. But this is far from what science fiction has taught us to expect in the future. So we're going to have to wait and see what progress they make over the coming years, but it will surely be exciting. If you liked this video, you might also like this video where I discuss how scientists have made quantum holograms. This is a pretty amazing piece of work. Thanks for watching, have fun, and see you next time.